Quantum computers, machines so powerful they could solve problems that would take today's supercomputers billions of years. They promise to revolutionize fields like cryptography, medicine, artificial intelligence, and materials science. But how close are we to actually building a functional quantum computer? And what challenges are we still facing? Welcome to Großdenken, everyone. In this video, we'll explain what quantum computers are, how they work, the progress we've made so far, and what's next on the road to making them a reality. Please support this channel grow by subscribing. That would mean a great help. Let's dive in. First, let's understand what makes quantum computers so unique compared to classical computers. Classical computers process information in binary form, using bits that are either 0 or 1. Quantum computers, on the other hand, use quantum bits, or qubits. Qubits are special because they can exist in a state of superposition, meaning they can be both 0 and 1 at the same time. This allows quantum computers to process vast amounts of data simultaneously. But that's not all. Qubits can also be entangled, meaning the state of one qubit is directly linked to the state of another, no matter how far apart they are. This phenomenon, called quantum entanglement, enables quantum computers to perform certain calculations exponentially faster than classical computers. So why do we even need quantum computers? What can they do that classical computers can't? Here are some examples. Drug discovery and materials. Science, quantum computers can simulate molecules and chemical reactions at a level of complexity that classical computers cannot handle. This could lead to breakthroughs in medicine and materials. Optimization problems. Quantum computers excel at solving optimization problems with many variables, such as improving supply chains, traffic flow, or even financial modeling. Cryptography. Quantum computers could crack current encryption methods, such as RSA, in minutes. This is both a challenge and an opportunity, as it drives the development of quantum-resistant encryption. Artificial intelligence machine learning algorithms could become far more powerful and efficient with the help of quantum computing. In short, quantum computers have the potential to revolutionize industries and solve problems that were once considered impossible. Now let's look at how quantum computers actually work. To harness the power of quantum mechanics, qubits must be created, manipulated, and measured. But here's the catch: qubits are extremely sensitive. They rely on delicate quantum states that can easily collapse, a phenomenon called decoherence. To prevent this, quantum computers operate in highly controlled environments. Most quantum computers need to be cooled to temperatures close to absolute zero, about -273.15 degrees Celsius, to minimize noise. They also require advanced error correction techniques to ensure accurate results, as quantum systems are prone to errors. Building and maintaining these systems is incredibly complex, which is why, honestly, quantum computing is still in its infancy. Despite the challenges, we've made significant progress in recent years. IBM has made quantum computing accessible through its cloud-based platform, IBM Quantum Experience. They've developed quantum processors with up to 127 qubits as of 2023 and are working towards scaling up. In 2019, Google made headlines by achieving quantum supremacy, demonstrating that their 53-qubit quantum computer, Sycamore, could solve a problem in 200 seconds that would take a supercomputer 10,000 years. Companies like Amazon, Rigetti, Honeywell, and D-Wave are also pushing the boundaries of quantum computing. D-Wave, for instance, focuses on quantum annealing, which is a specialized form of quantum computation. Governments worldwide are investing billions in quantum research. The United States, China, and the European Union all have large-scale quantum initiatives. Academic institutions are also playing a key role in advancing quantum technologies. While these achievements are impressive, today's quantum computers are still in what's called the noisy intermediate-scale quantum, or NISQ, era. They can perform certain tasks, but are not yet powerful enough for large-scale, practical applications. So, what's holding us back from building fully functional quantum computers? Here are the major challenges. Scalability. Right now, quantum computers only have a limited number of qubits. To actually solve real-world problems, we'll need quantum processors with, well, millions of qubits. Another big issue is error correction. Qubits are super prone to errors because of noise and decoherence. And developing error-correcting algorithms is honestly one of the biggest hurdles in quantum computing. Then there's stability. Keeping qubits stable long enough to perform calculations is extremely difficult. It requires ultra-cold environments and some pretty advanced engineering. And of course, there's the cost and complexity. Building and maintaining quantum computers is incredibly expensive, which means only a handful of companies, governments, and research labs can really access them right now. Despite all these challenges, researchers are actually pretty optimistic about overcoming them in the coming decades. So, how close are we to building a quantum computer that can actually change the world? Well, experts predict that we're still about 10 to 20 years away from large-scale, fault-tolerant quantum computers that can solve practical problems. But, progress is accelerating really fast. In the next 5 to 10 years, we'll probably see quantum computers solving specialized problems in areas like chemistry and logistics. As the technology keeps improving, quantum computers will eventually outpace classical computers in more and more areas, unlocking their full potential. While we're not quite there yet, the race to build quantum computers is definitely heating up. And honestly, the future looks incredibly promising. The future of quantum computing, well, it could transform our world in ways we can't even fully imagine today. From designing life-saving drugs to tackling climate change and even unlocking new physics, quantum computers could totally redefine what's possible. But with great power comes great responsibility. Quantum computers will also disrupt industries like cybersecurity, and that means we'll need to rethink how we protect sensitive information. Ultimately, quantum computing represents the next frontier in human innovation. And honestly, we're just getting started. Quantum computers are no longer just a theoretical concept, they're actually becoming a reality. While there's still a long way to go, the progress we've made so far is nothing short of extraordinary. As we keep pushing the boundaries of science and technology, one thing is clear. The quantum revolution is coming, and it's going to change the world. So, what do you think about quantum computing? Are you excited about its potential, or do you think the challenges are just too great? Let me know in the comments below. And hey, if you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more videos about cutting-edge science and technology. Until next time, stay curious.